Okay, next session this morning is going to be about innovative treatment solutions. Becky Schuerman is an extension educator at the University of Nebraska Lincoln, and she is going to talk about domestic drinking water treatment.
Good morning, everyone. Use the mic here. All right, we're going to talk about domestic drinking water treatment today. And the basic approach is to test your water in order to determine the water quality characteristics that exist, then identify the contaminants that you wish to remove, determine the most feasible solutions, and know where to find credible information so that you can educate yourself about those contaminants and treatment options. And remember that one system cannot treat all contaminants. A combination may be the most effective way to go. And ultimately, treatment systems are only as good as they are maintained. So what to test for? Private well owners should always test for bacteria and nitrates. Your bacteria includes your coliform and your E. coli. If there's any questions, you can always use a table from the drinking water treatment overview, which we have copies of in the back of the room afterward. That is a NEB guide that you can use to identify other possible water quality parameters to test for. And then it's always a good idea to check with your local NRD or health department for contaminants of concern in your area, because they will be the people that can help educate you about that. Possible solutions. Well, first off is your non-treatment. You've got your source water protection and the possibility of drilling a new well in a different location, possibly a deeper well. First and foremost, you always want your drinking water source to be uphill from your contamination. Keep it away from livestock area containment facilities, any septic systems, and such like that. Other non-treatment solutions include connection to a nearby community public water system. This would include your municipalities as well as your rural water systems. The use of bottled water for both drinking and cooking. Contamination generally cannot be taken care of by boiling the water. When you boil the water, you only concentrate it. Boiling only helps when you have bacteriological problems. And shock chlorination, it destroys the microbes. You introduce a high chlorine concentration into your well, and this sits in your system for a relatively short period of time. And then when you drain that chlorinated water from your system, you want to be sure to bypass your septic system, because if you don't, you're going to kill all the good microbes that exist there that are helping you with breakdown within your septic system. Treatment systems, you have your point of use systems for contaminant removal. This provides a centrally located tap where you will be able to reduce the risk of adverse health effects through the ingestion of copper, lead, arsenic, nitrates, and the other emerging contaminants, as Sue Dempsey spoke of earlier. Point of entry systems for contaminant removal, they provide a whole house filtration so that you reduce the adverse health effects from the ingestion, skin exposure, inhalation of gases, aesthetically unpleasing water for bathing or drinking, and when a contaminant is considered a household nuisance. That's kind of like describing a weed. Anything can be a weed if it's not wanted there. So anything can be a nuisance if it's not wanted. How much water do we use? This is a pie chart that was done in 2016, so it's fairly relevant and very recent. As you can see, there's a smattering across the board. None of these numbers are exact, but you can see that the amount of water that we end up kind of, so to speak, flushing down the toilet or down the drain incorporates a lot of the water that we use. Sediment filters. Large particles are captured. The small particles, chemicals, and metals pass on through with the water. Sediment filtration is considered a point-of-use device. It's often a pre-treatment for other processes. It removes the suspended particles and materials such as sand, silt, clay, any other organic matters or some pathogens. And there are different cartridges based on the size of the particles. So you'll have the smaller micron versus the larger micron size within your filter. You have your carbon filters where you have clean water going through and the carbon says, hey, I'll take all your contaminants, and it passes on through. The problem with carbon filters often is that they become saturated. And if people don't change them out on a regular basis, you end up having untreated water come right back out, and sometimes untreated water that has more than what it came through with. Activated carbon filters are also point of use devices. You have pitcher, faucet, your under sink filtration systems with a tap that usually is beside your kitchen sink tap. They can remove the chlorine, the taste, odor, lead, pesticides, and some of the other industrial wastes. And they're typically used in combination with a sediment filter because that extends the life of the carbon filter. We have RO, which is pressurizing water through a membrane, and then water as well as the excuse me, as well as the contaminants end up going out the drain. It's also considered a point of use device generally. Most people don't use whole house RO filters because of the fact that you do waste so much water. You have upwards of 95% of the removal of most of the contaminants. And a way to keep your RO filters and your membrane lasting longer is to put pre-treatment in. So you would have your sediment filters and possibly a water softener in line before your RO unit. Today, the wastewater ratio to filtered water ratio is about 3 to 4 gallons of waste to 1 gallon filtered. This has gotten a lot better over the years. And there are also some systems out there, although, of course, the price goes up a bit, that have no waste at all. You have distillation, where you introduce heat and do the evaporation condensation cycle. It's also a point of use device. Of course, it uses the evaporation condensation, so it creates the steam, and then the steam collected is your treated water. The contaminants either remain in the chamber or they boil off. Sometimes, as you saw in the previous diagram, they're caught up into a filter at the top. Most people would use a countertop unit. These units are based upon cost, and you have to figure out how many gallons per day of output you need in order to decide which unit you'd like to purchase. You have your ion exchange, most commonly known as our water softeners. But you do have cation exchange as well as anion exchange. So you have your softening process, but the problem with the water softener is it only lasts so long before it has to recharge. And so you have the constant recharge of the unit in order to maintain softened water. Hard water, it causes scale buildup within your household appliances as well as within your household distribution system, the piping within your house. This affects the performance of your appliances and can affect the water pressure within your household distribution system. Softeners, they remove nearly all the calcium and magnesium by removing the cations, the positives. And it may also remove limited amounts of iron and manganese. There are systems out there that do say that they can remove more iron and manganese. And if that is part of the reason why you're getting a water softener, you really need to take a look at the stats on that piece of equipment to make sure that it's going to be doing what you need it to do. Of course, the costs may vary depending on the required household flow rates. Anion exchange is a point of entry. Of course, it's different from cation exchange because you're removing the anions rather than the cations. You have up to 95% removal. It's very good with arsenic and nitrates. And the one concern is with the high sulfate levels that are left behind. Continuous disinfection for point of entry. You have it deactivates your microbial pathogens, such as your bacteria, your viruses. Ozone, UV, continuous chlorination are 3 types of it. They're really specialized treatment, not as often used with residential systems, and it's best to implement them working with a water quality professional. Never hesitate to consult the NEB Guide list for drinking water publications. We also have that at the back of the room. This lists all the publications that are within drinking water treatment, within drinking water contamination, as well as private well owner information. It's especially good for folks who are not familiar with having their own well, who have moved from an urban area out to a rural area. They often don't realize that they are now in charge of their water system. They have to be the ones testing it because the municipality is not there to do it for them. With that, that's it. Thank you very much. If you have any questions, that's my information.